All right, for today's video, we're going to do EOC review number 11. Okay, for the graphs below, graphs and tables below, label and determine all of the following that apply. So we're going to look at our X-intercept, our Y-intercept, our axis of symmetry, the maximum value, the minimum value, and where the function is increasing or decreasing. All right, so this first function here, this is a linear function. And with a linear function, we will have an x-intercept, which is right there. This is our x-intercept. And we will have a y-intercept. This function, because it's linear, is only going to be either decreasing or increasing, and this particular function is decreasing the whole time. So it's always decreasing. Because it has a negative slope. Okay? In graph number 2, we have two x-intercepts. Those are the x-intercepts. Our y-intercept is right there. Our axis of symmetry is going to cut right through the middle of that vertex. That's the axis of symmetry. This particular graph has a maximum value because it's a negative quadratic function, so it has a maximum value. And then it asks state where the function is increasing and decreasing. Well, this function is increasing at that point from and on the other half, once it hits the vertex, the maximum value, then it starts to decrease. And again, this is a quadratic function, and we should know that by now. That's why we have a parabola. All right, in number 3, we have an exponential function. We do not have an x-intercept because the asymptote would be 0 and it's never going to touch 0. But we do have a y-intercept, which is right here, and I will label that as our y-intercept. There is no axis of symmetry, and there is no maximum value or a minimum value for an exponential function. So the only thing left to determine is it increasing or decreasing, and this function is increasing. Okay, let's look at table number 4. Table number 4, let's see. I have x values of -2, -1, 0, 1, and 2. I can look at my y values and I can determine that if I'm going from -7 to -4, I'm adding 3. From -4 to -1, I'm adding 3. From -1 to 2, I'm adding 3. So because each time I am adding, that tells me that I have a function that is increasing. So this is linear and it's increasing in value. Okay, my x-intercept, I don't know by the table, but I can highlight my y-intercept because my y-intercept is when my x is equal to 0. So my y-intercept is 0, 1. And I'll try to make an arrow. That's my y-intercept. Looking ahead, when it asks what type of function is shown in table 4, well, I've already identified that as a linear function, so I can go ahead and circle that for number 6 as well. All right, in table number 5, I'm going up by 1s. I'm adding 1 to my x values. However, with my y values, I subtract 3, then I subtract 1, then I add 1, then I add 3, then I add 5. So I'm going to write it over here to the side. I have -3, -1, +1, +3. And you'll notice if I look at the differences here, to go from -3 to -1, I added 2. From -1 to 1, I added 2. And 1 to 3, I added 2. So this is a quadratic function. And I can tell that because of looking at these second differences from the table. Now, we do still need to determine our maximum value or our minimum value, and our x-intercept and y-intercept. Now I can determine by looking at this graph, at this table, that my vertex is going to be at 0, -1. So if my vertex is at 0, -1, and I'm just going to give you an example on this quadratic function above, and then I'm at -1, 0, and I'm at 1, 0, that means that function is opening up, so I'm going to have a minimum value, and this minimum value is right here. So that's my minimum. It's also my vertex. So what that means is that it's increasing on the right side of my table. And I'm just going to put increase because I'm out of room. And it's decreasing on this left side of the table. That's where it's decreasing. All right, we already did 6 and 7 because we identified what type of function it was, and that's a quadratic function. Oh, and I guess we forgot to do our x-intercepts and our y-intercepts. So our x-intercepts are when my y is equal to 0. So -1, 0, and 1, 0 are my y-intercepts. Not y, sorry, x-intercepts are what I've highlighted in yellow. And my y-intercept is where my x is equal to 0, which I've already highlighted in blue because that's also where the minimum value is. But I guess I should highlight that in orange so that it matches everything else. So this here is also my y-intercept. Oh, why I can't write today. Y-intercept is orange, which is right here in the center, which is the same thing as my minimum value and my vertex. All right, so the EOC review. Number 8, a table of values is given in the function f of x. So this f of x function is given to us in a table. And the function g of x can be represented by the function here as an equation. Which function will have the larger maximum value, f of x or g of x? So if we're looking at our maximum, remember our maximum is going to be our vertex. And so we need to find our vertex. And in order to find our vertex from a quadratic function, we're going to use our axis of symmetry formula, which is negative b divided by 2a. So I'm going to have a negative 4 divided by 2 multiplied by a negative 2. So that's going to be a positive 4 divided by a negative 2, negative 4, which is equal to a negative 1. So that's where my axis of symmetry is at negative 1. Now that I've found my axis of symmetry for my g of x function, I'm now going to take that axis of symmetry, so f of negative 1, and I'm going to plug that into my g of x function. So I should probably write that as a g function. So I'm going to find g of negative 1 to find my y value. So I'm going to do negative 2 multiplied by negative 1 squared minus 4 times negative 1 plus 1. And remember, all I did was plug in that negative 1 anywhere I had an x in this g of x function. Now I just need to evaluate it. Negative 1 squared is 1. 2 times 1, negative 2 times 1 is negative 2. Negative 4 times negative 1 is going to be a positive 4. And then we're going to add 1. So that is equal to, well, negative 2 plus 4 is 2 plus 1 is equal to 3. So the vertex of my g function is going to be negative 1 and 3. So the vertex of g of x is negative 1 and 3. Now the vertex of my f of x function I can determine by looking at my table. So my f of x vertex is equal to negative 1, 6. Well, how do I know that that's my vertex? Well, that's because that's where these solutions, my y values, start to mirror each other. And if they're mirroring each other, then that means that my vertex is at negative 1 and my y value is at 6. So if my f of x function, my f of x vertex is at negative 1, 6, and my g of x function, the vertex is at negative 1, 3, that means that f of x has the larger maximum. Okay, number 9. Susan is running a 5K race. The graph of distance versus time is shown. What interval is she running the fastest? So for what interval is the greatest rate of change? So we're looking at our slope or our rate of change. Remember, our rate of change is rise over run. So we're looking at how steep it is. Well, from 0 to 10, my slope is going to be 3 over 10. From 10 to 35, I only went up 2, so that would be 2 over 25. Well, this slope is much greater. This rate of change, 3 over 10, is a higher number. So she is running the fastest between the interval of 0 and 10. So 0 to 10 minutes is when she runs the fastest. Okay, last question, number 10. Sketch the graph of a quadratic function that has the following key features. So we're looking for a maximum of 2, 1. And I'm going to highlight the axes here because it's hard to see. So if I'm looking for 2, 1, 1, 2, and up 1, that's my maximum value. My x-intercepts are at x is equal to 1 and x is equal to 3. So this is x equals 3. This is x equals 1. This is 2, 1. My y-intercept is at y equals -3. This is where y equals -3. And there is my quadratic function. I should draw that just a little bit better. Make sure you indicate when you draw your parabolas that it is going to continue on forever. Many of you just seem to stop it at that 5th point, but it does continue going on forever, which is why your domain is all real numbers. So please make sure that you include these arrows at the end of your parabola. Thank you. That's it for homework review number 11. Don't forget to turn these all in at the end of the week.